For many years, astronomers have kept a careful watch on one of the most dazzling and enigmatic stars in our night sky, Betelgeuse. This immense red supergiant teeters on the brink of collapse. Experts have long warned that an explosive finale is near, though they could never determine precisely when it would occur. Now, in a groundbreaking breakthrough, the James Webb Space Telescope has captured what was previously thought unattainable, the exact moment when Betelgeuse began to explode. This observation is far more than routine astronomy. It is a rare and historic event, marking the closest supernova ever recorded by humanity. The data collected by Webb is transforming our understanding of how stars die. Situated in the shoulder of the Orion constellation, Betelgeuse stands apart from ordinary stars. It is a red supergiant with a diameter more than 700 times that of our Sun and a mass roughly 20 times greater. Astronomers have long known of its instability, as the star frequently expands, dims, and erupts. When Betelgeuse suddenly dimmed in 2019, it sparked global speculation that its anticipated collapse might be imminent. However, Webb's unprecedented precision has deepened the mystery. For the first time, scientists are witnessing in real time the signs of a star in its final throes: enormous bursts of energy, chaotic magnetic fields, and erratic surface convection. Betelgeuse is not simply dying, it is transforming before our very eyes. For months, the James Webb Space Telescope has been focused on Betelgeuse, using its infrared capabilities to peer into layers of the star previously hidden from all other telescopes. The data returned is extraordinary. Astronomers can now observe massive convective bubbles erupting on the surface, some as large as Jupiter. Jets of superheated gas surge into space at incredible speeds, while spectral analysis reveals shockwaves rippling through the star's outer shell. For the first time in history, scientists are directly witnessing the physics behind a star dismantling itself. This is not a simulation. It is a live dissection of a supernova occurring just 642 light-years from Earth. Unlike supernovae that happen in distant galaxies, Betelgeuse's relative closeness means its explosion will not only be easily visible, but could also outshine the full moon, shining so brightly it might be seen even during daylight. Beyond the breathtaking spectacle lies an even more important opportunity, a rare chance to observe a star's death up close. This event allows astronomers to study the collapse of a stellar core, the creation of essential elements like carbon and oxygen, and the powerful shock wave that reshapes everything in its path. What Webb has captured goes beyond a star's dramatic end. It reveals the very process by which the universe is enriched with the fundamental building blocks of planets and life itself. In a profound sense, we are witnessing our cosmic ancestry unfolding in real time. Betelgeuse's explosion is not just an astronomical event, it represents a crucial chapter in the story of how galaxies evolve, planetary systems form, and life's cycle continues across the cosmos. Thanks to Webb's unmatched capabilities, scientists can now study a star's final moments in incredible detail. This new insight could eventually allow astronomers to predict future supernovae by detecting early warning signs in other stars. The significance of this discovery extends beyond pure science. It is a moment of deep wonder, offering a glimpse into the vast stretches of cosmic time suddenly brought into focus. Betelgeuse's detonation is not an isolated incident. It sends powerful waves of energy throughout space, disrupting the interstellar medium for light years around. Webb has already detected the first tremors, high-energy particles racing outward, energizing distant gas clouds and reshaping the dusty envelope that once surrounded the star. Moreover, the data suggests an even more profound phenomenon: detectable shift in gravity. Despite being 642 light-years away, the collapse of Betelgeuse's core may have produced gravitational waves, subtle ripples in space-time that scientists have only recently learned to detect. If confirmed, this would be the first time a visually observed supernova is directly linked with gravitational wave data, potentially revolutionizing our understanding of how light, matter, and space-time interact on the most fundamental level. Betelgeuse collapses, a profound question emerges. What remains after the explosion? A neutron star, a black hole, or something entirely different? Webb's data indicates the collapse may not be uniform. Researchers have observed magnetic disruptions, plasma voids, and possible asymmetric fallback, where matter does not escape but falls back inward. Some scientists are even hypothesizing the existence of a transitional object, a theoretical stage between a neutron star and a black hole that has never been observed before. If Webb has indeed captured this, it could represent the first solid evidence of a new class of cosmic body. Given Betelgeuse's relative proximity, some have wondered whether Earth is in danger. The short answer is no. The star is not close enough to pose any harm. However, the explosion will release intense waves of particles, gamma radiation, and electromagnetic bursts that could disrupt cosmic dust clouds, affect nearby star systems, and alter how light travels to us from distant regions. Webb is currently monitoring the radiation speed and spread carefully. While Earth remains safe, this event may change the way we observe our universe by modifying the local cosmic environment. Betelgeuse is vast, ancient, and awe-inspiring, yet it is dying. Its fate is a solemn reminder that even stars, those seemingly eternal points of light, have their limits. What Webb has revealed is not just a star's death, it is a reflection of the universal truth that all life must end. Yet in every ending there is creation. New elements are forged, new stars will be born, and new planets may arise from Betelgeuse's remains. This is not mere destruction, it is cosmic renewal, and we are privileged to witness it. Among Webb's vast collection of data, scientists have uncovered something extraordinary, rare variations in the elemental composition of ejected material. Alongside familiar elements like carbon, oxygen, and iron, the explosion released exotic elements such as technetium and yttrium, materials formed only under extreme stellar conditions. This discovery is vital because by analyzing these elemental ratios, scientists can trace the complete life cycle of matter throughout our galaxy, from dying stars to the cosmic dust that forms worlds, and ultimately to the atoms within our own bodies. Betelgeuse's story is ancient, predating Earth itself, and it will not return. The brilliant star that once marked Orion's shoulder will soon be replaced by a growing cloud of incandescent gas and glowing remnants. But this is not just an ending, it is a profound legacy, a gift of knowledge about elemental birth and cosmic awareness. It serves as a poignant reminder that our own sun will one day fade and that every bright point in the night sky is writing its final chapter. Yet from these celestial conclusions, new stories will begin. Without the explosive death of stars, there would be no worlds, no oceans, and no life as we know it. Now, through the eyes of the James Webb Space Telescope, we witness this eternal cycle where stellar death fuels creation. In the quiet vastness of the cosmos, 642 light-years away, a star has reached its end, not in silence, but with a brilliant outburst of light that has traveled across time to reach us. Thanks to Webb, we have not only observed this moment, we have understood it. We have traced the signals of collapse and eruption, not as myth but as tangible reality. Betelgeuse's demise was not in vain. In its final burst, it answered ancient questions predating humanity itself. Where do the elements come from? How? Do stars end their lives? And what fate awaits our own sun? Through its fading brilliance, Webb has unveiled more than a supernova. It has revealed the story of our cosmic origins and offered a glimpse into the future. If you enjoyed this overview, please like, share, and subscribe. See you soon.